Now, an important result using this process is that we can find the antiderivative of tangent x. So, what do you think? What do you think the antiderivative of tangent x is? Just think about it for a minute. What do you think is the antiderivative of tangent x? So it's not secant squared. The derivative of tangent is secant squared. If I want to find an antiderivative of tangent, then I need to find tangent on this side of the list. But there is no tangent on this side of the list. I know the derivative of tangent, but I don't know the antiderivative. There's no simple direct way to do it. Now, by the way, when I say I don't know the antiderivative of tangent, I'm not being humble. I actually don't know it. I don't memorize this. What I do instead of remembering what the antiderivative of tangent is I remember the process by which you get it. So what I do is I think, oh, okay, yeah, I know what that is. It's like you use a substitution. And so what you do is you think of tangent x is sine x over cosine x, all right? And then you think of using the denominator. So a denominator is often a good pick for a u if you don't, like we don't have an obvious inside function here. How is this substitution? There's no obvious inside function. Well, a denominator can be like an inside function because it's inside the function 1 over x. So what I do is I pick u equals cosine x. And then I do du equals negative sine x dx. Now over here I have positive sine x, not negative sine x. So I'm just going to pull over the negative. Negative du equals sine x dx. Then I can replace sine x dx with negative du. So I'll put the du here and I'll put the negative out. All right? And then I don't have anything left in the numerator, so the numerator is 1. And in the denominator, I'm substituting cosine x, which is u. All right? So there you go. It's integral of negative 1 over u. Now, what's the antiderivative of negative 1 over u? Am I going to write it as u to the negative 1 power? And then raise the exponent 1 to get u to the 0, and then divide by the new exponent, which is 0? No, because that would be undefined. What's the antiderivative of 1 over u? Oh, that one is on the list. The antiderivative of 1 over x is ln of x. All right? So that means this is negative ln of, but we got to remember that it's absolute value of u. So whenever I do antiderivative of 1 over u, it's ln of absolute value of u. That's important because otherwise we lose a lot of the domain of this integral. Plus c. So we did a plus c because I did the antiderivative. Now I just plug in my cosine, so I have negative ln absolute value cosine x plus c. That's the antiderivative of tangent. So, I never memorized this one. I didn't put it on the list of things you should memorize. I don't memorize it. What I do is instead I remember the process by which you get this result. So in a lot of mathematics, seems like it's just memorizing a lot of big crazy formulas, but you actually almost always have a choice that instead of memorizing a result, you can instead remember the process. And so you can sort of divide up your brain into storage space and CPU space. For me, this one goes into CPU space, right? It's easier for me to just calculate it every time than to use up some of my brain storage space remembering that result. It's easier for me to remember the process. And then, by the way, you could do the same thing for integral of cotangent. You might want to try that as just sort of entertainment while I try to find what I wanted to do next out of this book. Let's see. Oh, yeah, we're going to do number 34. All right. Oh, yeah, that's a good one. Okay. So now I'm going to look at, so this was not in Rogowski. That was just an example of something we could do. Here's Rogowski, page 334. Number 34, and here's a crazy looking thing. It is integral of 2x squared plus x over 4x cubed plus 3x squared dx. What a crazy thing. All right, so what are you going to do with something like that? Something you should always look for in a rational expression, and we're going to get these rational expressions are going to become increasingly involved, all right? But look for a numerator that is a constant multiple of the derivative of the denominator. So look in your denominator, whether there's a squared here or not, and say, okay, let's try using the denominator as u. Then what would du be, and does the numerator look du-ish? Well, du here would be 12, now this is just scratch work that I'm writing here. It's just sort of thinking out loud. The du would be 12x squared plus 6x. Now if I divide all that by 6, I get 2x squared plus x. So that is a constant multiple of what I have up here that's du-ish. So that tells me that it's going to work to use u equals my denominator here, which is 4x cubed plus 3x squared. And I'm going to leave this squared out of it. And essentially I'm going to have 1 over u squared, or u to the negative 2, as my... Thank you, Gertie. You can just sit right there. Jeez. Okay. So my du is 12x squared plus 6x. All right, but I want just 2x squared plus x. So what I'm going to do is I'm going to multiply all of this entire equation by 1/6, and then I will have 1/6 du equals 2x squared plus x, which is exactly what I have up here. All right, so now I'm going to take my 2x squared plus x dx, and I'm going to replace that with 1/6 du, and let's just right away put the 1/6 outside the integral. We can start doing that. All right, and then my denominator in here has a square on it, but I have nothing left in the numerator, so that numerator is going to stay 1 again. And at the bottom I've got u, but that u is squared. Okay, so it's just a matter of following the substitutions. We're going to have u be... The cat really wants to push my notebook downward. All right, fine. I will, of course, submit and move my stuff. All right, so that she can sit right there. And she keeps like pushing it forward. All right, so look for a u in the denominator. Look to see that the numerator is du-ish. That is, it's du within a constant multiple. Work out your du, adjust your du, take your fraction, or maybe it could be a whole number, put it outside, and then go through and integrate using what we already know. We call this u to the negative 2 du. I still haven't done the antiderivative. Now I'm going to do the antiderivative. U to the negative 1 over negative 1 plus c. You could skip that and just directly fight with a cat. Make this negative 1 over 6u plus c. Make sure you sub the u back, so I have negative 1 over 6 times 4x cubed plus 3x squared plus c. And that's that one. Nice challenging one there. Don't you agree, Gertie? I think that one's nice and hard. Yeah, Gertie? Or are you going to just totally ignore it? You're not even going to do your math homework today? Come on, Gertie.